Hello, everybody. This is your very own Mr. Lakin. My voice sounds a little bit weird because I've been coughing up nasty mucus. And I have no idea how much coughing I'll do during this video, but that should be fun to see. Let's see. We're going to do problems number 22 and 25 for section 4.2. Okay, here's 22. So there's two. All right. First thing that I'm going to do here is take the summation and break it up into two parts. I like doing that. So I squared, the minus can come right outside. I equals 1 to 10 of 1. Okay, now you'll have to remember the properties. So there were two of them. One of them was the sum from I equals 1 to n of I squared was equal to n times n plus 1 times 2n plus 1 over 6. The second, oh gosh, the second one was I equals 1 to n of some constant is equal to some constant times the number of terms that you have. So let's go bit by bit. This one, n is 10, so don't forget that. We're just going to plug n into that formula for this part. So we're going to get 10 times 10 plus 1 times 2 times 10 plus 1, all divided by 6. For the second part, we're going to minus, and it looks like I just have to do C 1 times 10. Okay. So minus 1 times 10. Okay, there you can see it all at once. And then I simplify. This is a no calculator problem. Don't even think about using your calculator. All right, let's see what we get here. 10 times 11 times 21 over 6 minus 10. Let me show you tricks of the trade here. So we got a 3, that's a 2, that's a 7. I divide those two factors by 3. And then I'm going to divide these two factors, a 2 and a 10, by 5. And I get 35 times 11. And 35 times 11, well, that's, when I multiply by 11s, I can do 5. Then I add these two numbers, and then I get 8. And I get a 3. So I get 385 minus 10. Extend the page. 85 minus 10 equals 375. Woohoo! I'm going to check this on my favorite program, Desmos. Mr. Lakin, you have a lot of tabs open. True story. Okay. 1 to 10. Right. Haha, 375. That is number 22 for you. Hope this answered your question that you had. Let's go to the next one. Okay, now this one was for number 25. So for this one, I can see why you asked about this one. For this one, it's that n squared that's the problem. So in order to take care of that, what we're going to do is first rewrite the summation. Notice how in calculus it's just a lot of rewriting of n of 2i plus 1 times 1 over n squared. Because that 1 over n squared ain't doing anything. And remember, it's not dependent on I. In fact, if I want to, I could take it out of the summation so it's less confusing. And I could break up that summation again. Okay, close the brackets. And you're thinking, but Mr. Lakin, can't you take that 2 out? Yeah, I can. Let me take that 2 out. By 2. Hello, 2. Okay. So we have 1 over n squared, 2e, 2 some, oh my gosh, 2 times the sum of I equals 1 to n of I plus the sum. Okay, now I'm good to go. Let's actually simplify more. I lost my train of thought here, but now I got it. Let's go and simplify more. The sum for I, the formula, is n times n plus 1 over 2. Keep in mind that we have this lovely green 2 here. And then plus, let's get this little part here, plus n. Okay. Next, let's simplify in the brackets first. So again, algebra idea now. So let's just simplify before we start doing anything crazy. So first thing I can do is I can take out those 2's, bye-bye. And now let's go ahead and distribute the 1 over n squared in. So we got n plus 1 over n squared plus n. Okay, that's it. Now, wow. Oh, holy moly, that's not it. Plus n over n squared. Okay, I'll keep combining. Lots of simplifying here. N squared, this gets us plus an n, so plus 2n over n squared. Okay, that simplifies more. You can factor the top as n plus 2 over n squared. Wow, that was really a lot of simplifying. Okay, but that's what you get as your answer. Now, we can just plug in any number that we want for n. In this one, it looks like we're plugging in 10, 100,000, and 10,000. So let's start doing it. When we plug in 10, make a little table here. When we plug in 10, he sounds crazy. Whoa. Okay. All right. I just want to extend this line. That's not going to work, is it? Okay. All right. That's just not helpful. Hold on. I'm almost done. Feel free to fast forward through this part. There we go. Okay. When n is 10. So we have 10, 100, oh, what? 10, 100,000, and 10,000. Okay. Let's do 10. Let's do that in green. So 10 will be 10 times 12 over 10 squared. Easy peasy, no calculator necessary. We get 12 over 10, which is 6 over 5. Again, the numbers look scary, but because you got that, oh my gosh, did I not do that? Look at this, guys. I could just do n plus 2 over n. Oh, it's so much easier. All right, that makes my life a lot easier. So see what simplifying can do for you. Just makes it a lot easier. If I do 100, I get 100 plus 2 over... Oh, man. Hey, I'm still sick, so you can't... I'm trying to make a video for you. I'm trying to be helpful, but obviously I'm just not up to it yet. Okay, 100 plus 2 over 100. This is for 100 when n equals 100. I get 102 over 100, which I believe is 51 over 50. For 1,000, I'm going to see a pattern here emerge in a second. Again, my formula was n plus 2 over n, so I'll get 1,002 over 1,000. I believe that's going to be 501 over 500. Okay, kind of seeing a pattern here. And then that means that this is probably going to be 5,001 over 5,000. That's it, guys. This is how you did problem number 25. Hopefully this was helpful because I know I kind of messed up a few parts. I lost my train of thought. My nose got stuffy during the video. But anyway, there you are. Thank you for watching.